Hi everyone, and welcome to our lesson here on the dock. Our show today is Ocean Waste in Bad Taste, and we are going to take a look underwater in Bamfield Inlet to see what we can find for ocean pollution in Bamfield Inlet. So let me introduce you to the team that's helping out here on the top side, I guess. My name is Kelly, and then behind me is Owen. There's Owen. He's holding a very fancy contraption that is designed to help him view the screen of our ROV, which I'll introduce you to in just a moment. Behind Owen is Bianca back there on the dock. She's helping to mind the ROV as it goes in the water, and that cute little yellow thing, let's get a closer look. That is our ROV. If you've watched one of our BMSCLive shows before, maybe you have met the ROV. It's about to go for a dive in the water. So that's a pretty exciting thing that we've got coming up for you. We also have a guest speaker that will be joining us a little bit later on. So I will introduce you to that guest speaker in a moment. But for starters, I think you are all excited to go for a dive underwater. That's the coolest part about these lessons from the Bamfield Marine Sciences Center. We get to actually take you underwater through Zoom, of course. So let's get the ROV fired up. We're going to get it into the water and we'll start doing some exploration. Now, if you've watched one of these shows before, maybe you watched as we explored some of the different marine life in Bamfield Inlet, living right underneath our docks. There's lots of cool animals and seaweeds down there. However, today we'll look at those things too, but we're also going to be trying to look around and see if we can find some trash or some garbage in the ocean. So I'd like to ask you a question as we start to get the ROV ready. If any of you can think of ways that garbage might end up in the ocean, how does it get there? And you can put your answers into the chat. They'll pop up right here on my screen and I can see your responses as we go along. So how does garbage end up in the ocean? Okay, I'm seeing litter. Absolutely. Sometimes humans by mistake or intentionally might drop bits of garbage in the ocean or dump lots of garbage in the ocean. That does still happen. Good. Any other ideas of where garbage ends up into the ocean? From beaches, also a good option. Yeah. So when you visit the beach, maybe you have an unfortunate situation where some of your trash flies away, lands in the water, could go into the ocean from there. Yeah. All right. I'm not able to see the ROV. Is it working yet, Phil?
Yeah, I have you both in the spotlight, so I'll.
Okay, I just gotta find
it.
it.
See the full ROV.
Okay, here we go. It's coming into view now. So the water looks a little bit murky today, as you can see, and we're just cruising down underneath the BMSC docks here. So what we're looking at is one of the pilings, which is a wooden post that is supporting the docks that we're standing on. And we're going down, down, down to the seafloor through that cloud of what looks like plankton to me. There's lots of little bits of things like plankton floating around in the ocean. So, okay. We talked about some of the ways that garbage and plastic might end up in the ocean. Now that we're underwater, we're looking around. Can you think of any impacts that might have on the ocean? So if there's garbage in the ocean, what is that? Why is that a bad thing? What would happen for this environment that we are now exploring? And Phil, I might have missed one of the answers that came through there. I saw it could kill turtles.
Yep.
Yes.
Yeah, it can also kill fish, and the ocean will get disgusting. Definitely poor for fish.
Yeah, absolutely. Oh, and are the lights on the ROV? It's very murky under there. So the lights are on our ROV, but it's very difficult to see much of anything today just because of the time of year. This is September at the time of filming this. It'll go on to our YouTube channel, so I'm just making a note of that. And this is pretty typical ocean conditions where warm remnants of summer temperatures have created lots of living plankton in the water. Oh, there's a beautiful rockfish for you all right there. And behind the fish, so it's a little bit difficult to tell exactly what we're seeing here, but we have actually found some ocean trash right here off of the BMSC docks. Any guesses of what this thing is that we are looking at right here? It's not made of plastic. It's quite large, actually. It's maybe about the size of a human, you might say. It's not a can. It's bigger than a can. A pole? Nope. Not a beam. It looks like a boat. That's the closest answer yet, but it's not a boat either. I love this. I know it's kind of murky down there, so it's tricky to tell. A robot. Nope, not a robot. A sail? Good guess. No, it's not a sail. Not a rock either. This is a human-made thing. Not a garbage bag. It's not something that you would normally expect to find in the ocean. This shouldn't be here. And it was dumped off of the BMSC docks many years ago, probably about 50, 60 years ago, and somebody did guess it. The answer is bathtub. This is a bathtub that has been dropped off the docks at the Bamfield Marine Sciences Center before it was the Bamfield Marine Sciences Center in its old days as the Pacific Cable Station. And there's a bathtub still sitting down there at the bottom of the ocean. So is this type of ocean pollution bad? What's it doing down here? Or maybe a better question is, how long do you think this bathtub might last underwater? Is it going to decompose? And if it is, how long do you think that might take? Oh, there's a sea star. It's a nice little leather star down there. So how long do you think it would take for a bathtub? Let's say it's made of porcelain, maybe. We've got a guess of 100 years, 5 years. How long does it take for a bathtub to disintegrate and decompose on the ocean floor? Maybe 1,000 years. Whoa. 10 years, 1,000 years. Lots of great guesses coming in. 80 years, 50 years. There's a year that has a lot of zeros on it that I don't even know what number that is. And we're looking at a lot of planktons streaming past our camera on the ROV today. Yeah, those of you that are guessing those numbers with a lot of zeros on them, there's quite a few of you. I think the correct number of zeros is probably about 6, but you know what? We don't actually know. So maybe about 1 million years for a porcelain bathtub to actually break apart and disintegrate completely so that there's no trace of it. But of course, humans haven't been around for that much time to actually monitor how long it takes for a bathtub to disappear out of the ocean. So we're kind of speculating on that number a little bit, but it's true. That is a bit of trash in the ocean that is probably going to be there for a long time. Now, in the grand scheme of things, that kind of trash isn't actually that harmful. So having a bathtub in the water it's probably not harming anything. I don't think it's killing any fish by being down there or making the ocean really that dirty or bad. There's lots of other types of pollution in the ocean that are much worse and much more severe. Anyone? Oh, that's a beautiful fish that we're seeing there. It's a type of rockfish. Nice. We're just taking a look around too to see if there's any other trash that we can find on the ocean floor around Bamfield. So we are a marine science center, and we try very hard to look after the environment and keep this place kind of pristine. However, there's also a lot of years of history from when humans were maybe a lot less careful about how they treated the ocean and what they dumped into it. So we're still kind of feeling the effects of those past human interactions with the ocean. There's a tube-dwelling anemone down there. I saw. There it is. That's called a tube-dwelling anemone. It lives sort of burrowed into the sand and the sediments at the bottom of the ocean, and it can retract down into the sand if it gets scared, if a predator comes along, or maybe even if the ROV came along and got too close, it might retract into the sand and hide. One of its favorite, or one of its most fearsome, I should say, predators is a type of sea slug. We get some big sea slugs in our area that like to eat tube-dwelling anemones, believe it or not. Okay, so as we're looking around under here, we're seeing a lot of bits of shell and sand on the ocean floor. We're seeing some animals here and there. That white fluffy thing was another anemone, a type of sea anemone that's a little bit kind of fluffy looking. I want to bring us maybe back up to the surface for a little while to talk about some more types of ocean pollution that we typically find on our shoreline. So let's just take a little break from the ROV here. We'll bring that back up to the surface, and we will come back to the ROV a little bit later on in our show to do a little bit more looking around. But for now, let's come on up to the surface, and maybe Phil, if you can spotlight my video again here. I want to show you some ocean plastics that we have retrieved from beaches in the area around Bamfield. So we did a little bit of hunting before this, before today, to look at what we could find on our beaches. So I'm just gonna flip my camera around here. I can see the ROV coming up to the surface here. There it is. It's back at the top. Okay, so our team is going to take that out of the water. And meanwhile, I'm going to show you some items that I've got over here in a bucket. So we found some items, and these are little bits of trash that have been found at beaches in our area. So we have some colorful bits of plastic. These are all just various small chunks of ocean plastics that were collected off of Pachina Beach in our area. That's what this yellow jar is as well. Down here, we have a piece of a plastic bag. I've sort of stuck it underneath one of the jars to hold it down because it's a little bit windy here today, and I really don't want it to blow away and go back into the ocean. There's a toothbrush and the pale little sand shovel handle that was found on the beach around here, some yellow rope, and a pop bottle, a plastic pop bottle. So I'd love it if you could take a guess at how long, oh, and these small little bits right here, I didn't mention our glass, sea glass, a blue piece and a dark green piece of sea glass. And there's a rubber boot in here as well. We didn't actually find that on the beach. We took that out of our cloakroom here at the Science Center. But how long do you think, you can take a guess at any one of these, for the pop bottle maybe is a good one. How long do you think it would take for a Coca-Cola bottle or any type of plastic water bottle to break down in the environment? How many years? And it is years, it's not days. How many years for that to decompose in our area? Think about that. Type your answers into the chat. A couple of answers coming in already. 10 years, 1,000 years. Wow. Yeah. Other types of plastic that are in here. There's lots of little bits of rope and mesh and little bits of plastic that it's kind of hard to even tell where they came from. Great, lots of guesses, lots of answers coming in. And a lot of you are in the right ballpark here too with your answers. For a plastic water bottle, the answer is about 450 years. Isn't that a little bit shocking? And again, humans haven't been checking on things for 450 years, so we don't actually know the exact answer. This is sort of speculation again, but that's a long time for this kind of plastic to remain in the environment. Something like a toothbrush. We all use toothbrushes. This is a plastic one. Again, it was found on Pachena Beach. It's a little bit decomposed, so some of the bristles are missing. And it's all smoothed out. It feels really like it's been sanded down, probably because it's been twisted around in the ocean a lot. Those are also probably in the neighborhood of 500, maybe 600 years to decompose. Same with this yellow piece of rope right here. That sort of thing. If you find that on the beach, it's going to take a lot of years for it to decompose in the environment. And so I should mention, when I'm using the words like decompose, that doesn't actually mean that it's going to disappear entirely. What unfortunately happens is that usually it breaks down into smaller and smaller particles, and that can also be really bad, because to humans, to our naked eye, it looks like, oh, it's gone, it disappeared and decomposed, but actually it just got really tiny. So I'm going to ask you another question here. In this jar, I don't know how well you can see this. Any guesses what those are? I've put them in a jar just to keep them contained. Oh, it looks like salt crystals. It's not salt. Looks like salt. Also looks a bit like rice, and to be honest, they're about the same size as rice, grains of rice would be. Decomposed plastic? No, it's not that. Although they are plastic. I'll give you that one. Not wax. These have a very special name. They are called nurdles. And nurdles are little plastic pellets. And they were found washed up on the beach just like this. They came from Pachena Beach in our area. Any guesses as to what a nurdle is used for? Why do these even exist in the world? Yeah, Phil spelled it for you. Nurdles is how it is spelled. It's a funny word. What is a nurdle? I love that we've maybe stumped some people. Excellent. Excellent. I often go nurdle hunting when I visit Pachena Beach. It's sort of a pastime that I have. And so it took me quite a few years to actually collect all of these nurdles off of Pachena Beach, but there's also quite a lot of them in here. You don't eat them, not intentionally at least. Unfortunately, some birds or marine animals might eat them by mistake, though. So that's not good. I don't think anybody knows what they are. This is exciting. Okay, so plastic nurdles, these little pellets, are where plastic items come from. Yeah, to create bigger things. So what they do is they ship these all over the world to different factories that melt them down and shape them into whatever type of plastic we need, whether it's a water bottle or a plastic sand bucket or any number of plastic items that we use in our day-to-day lives. They often start out as these tiny, tiny little nurdles. So what happens if a container ship carrying a bunch of nurdles accidentally dumps them overboard in the ocean? Well, now all these things are floating around out there in the ocean. So that's going to have some definite impacts for the marine life that is there. And believe it or not, this is actually not the smallest version of plastic out there in the world. It gets even smaller than a nurdle. And so for this part, I would like to invite our guest speaker to join in with us today. Her name is Lori-Jon Waugh. She's joining from the University of British Columbia, where she is a graduate student, which means that she is she's doing a degree after finishing her original undergraduate degree. It's another degree, a bigger project, all about a special kind of plastics called microplastics. So Lori, if you go ahead and turn on your camera and unmute yourself, I would love it if you could join our show. There she is. Thank you so much for joining, Lori.
Hi there. Happy to be here. I have a presentation to share if that's all right. Awesome. Let me see if I can do this easily. Okay, fantastic. So hi everyone, my name's Lori. And I'm just going to, join the chat here to talk to you about microplastics in particular. I do a lot of work in my degree studying the abundance of microplastics in the Strait of Georgia and the Salish Sea, which is the coastal waters in between Vancouver and Vancouver Island. So quickly, just a little bit about me. I'm originally from New Brunswick, and I came here to attend UBC for my undergraduate degree to study chemistry and oceanography back in 2015. And since then, I've graduated and moved on to a graduate PhD program at UBC again. And I'm supervised by Maria Maldonado, who is a researcher who's really interested in looking at contaminants within the coastal waters nearby Vancouver. And so we've partnered with OceanWise, particularly the plastics lab at OceanWise, who are interested in looking at microplastic pollution and not just monitoring it, but actively working to inform industry leaders and the government and of course the public on ways that they can avoid microplastic and plastic contamination in general. And that's just a photo there at the bottom of the Bay of Fundy, which is located in my home province of New Brunswick. It's the highest tides in the world. And that was my dog, Hallie. So yeah, so before I get into what I do, I just want to let you know what microplastics are, in case you don't know. So microplastics are basically plastic particles that fit in the size range between 5 millimeters and 1 micrometer. And a micrometer is basically 1,000 times smaller than a millimeter. So these are very small particles. And in order to really see them, you need to be looking at them under a microscope. So you look at microplastics under a microscope, and what you see are these sort of images here. And so what you'll often see are what we call secondary microplastics, which are microplastics that are formed from the fragmentation of larger plastics. For example, that Coke bottle that Kelly found at Pachena Beach that could eventually break down in the environment to form secondary plastics. An example of that is a small piece of styrofoam plastic that was found in the Fraser River nearby Vancouver. We also have what we call primary microplastics, which are plastics that when they were manufactured and used by consumers, they were made to be micro size. So they were made to be small. Examples of that would be microbeads, which are used in consumer products like no longer in Canada, but still some places in the world still add these to cosmetic products like face washes. Another example would be, and this is the most abundant that's found in the coastal waters of Vancouver, are microplastic fibers, which are coming from textile materials like your fleece sweaters that, you throw your fleece sweater in a washing machine, and the wastewater generated from that machine, while processed, some of those fibers that are in that wastewater end up into the ocean. And another example is glitter. These are, of course, primary microplastics. They're meant to be very small, and we do find them in the environment. And to just give you a little bit of an idea of what's happening with microplastics, you see microplastics come from a variety of sources. They can, of course, come from the atmosphere. Just imagine your sweater actively shedding fibers. This is plastic dust that's ending up in the atmosphere and then can be deposited in the environment in the Strait of Georgia. Another way that microplastics can enter the environment is through stormwater drains. So plastics that are littered on the ground can wash through these stormwater drains into the Strait of Georgia. Of course, like I mentioned, washing machines. This goes through wastewater treatment plant. And while that wastewater is processed, and about 90% of the fibers that are the fibers that are in wastewater are removed during that primary treatment, which is, for example, at the nearby wastewater treatment plant Iona in Vancouver, that is the way that they treat their wastewater. Even still, 10% of those fibers are still in the water that makes it into the Strait of Georgia. And so once these go into the water, a number of things can happen to them. They can, of course, fragment. So beach litter, for example, larger pieces of plastics that fall off of boats or that are just directly littered into the water, these plastics can break down and fragment into smaller pieces, secondary plastics. That can happen to fibers as well. So fibers can also fragment. And so once these plastics are in the water, they can also produce a biofilm, which is basically bacteria cling onto the surface of these plastics as a sort of a hotspot for them to grow under favorable conditions. These plastics can also be ingested by organisms, which is the primary concern when you think about plastics in the ocean. What is it doing to our wildlife? And that is an entire research section. Entire research section that I can't really get into today, but that is a huge area of research. Another thing that can happen is they can ultimately sink and end up in the sediments. And another way that they can move around is basically circulate through the ocean and end up into the larger water bodies, such as the North Pacific or even the Arctic Ocean. And so what my team does is, we're really looking towards measuring microplastics, specifically in the Strait of Georgia and the Salish Sea nearby Vancouver, by measuring microplastic concentrations or abundances in different sources nearby the Strait of Georgia. So that involves sampling for microplastics from wastewater, from the air, from stormwater, from beach litter, and figuring out what are the inputs of microplastics into the strait and quantifying that input, trying to determine the actual amount. And then another thing that we're doing is we're sampling the actual water column within the Strait of Georgia at different depths and at different locations in the strait, because we have a good understanding of the way that different water masses move in the strait, and we can tie that into transport processes from different source inputs. Another thing that we're looking at is measuring the microplastic concentrations in the sediments and in smaller plankton to understand those other mechanisms as well. And we're making new use of technology such as Raman spectroscopy, which is basically a method that where you shine a laser at a particle and then you measure the light that scatters off of that particle. And what happens is that signal is actually sort of like a fingerprint or a barcode for a chemical, such as a polymer. So we can fingerprint our particles in our samples by polymer. So for example, polyester or nylon. We can also fingerprint it for the extent of aging in the water or weathering. And then we'll also be describing these particles by size and shape, of course. And so this is just some images to get you familiar to the way that we're sampling. So we work with the Coast Guard in Vancouver, and we sample off of their hovercraft system. What happens is they set up a platform here and so that we can hang instruments off of the dock and send them into the water to collect samples. We use these instruments, they're large volume pumps. So basically these pumps are inputted into the whatever depth we've decided, and they filter large volumes of water through different mesh that we use to collect the plastics. And this is just an example of what a microplastic sample might look like. And because sampling microplastics is sort of a new field, and microplastics are basically all around us, and currently I'm wearing microplastics, so it's very easy to contaminate them. And because microplastics are such a diverse group of particles, they range in size, shape, and the actual chemical, content, it's really hard to sample these plastics and to quantify them. And so a few questions you have to ask is, what criteria do you even use to detect microplastics? Because microplastics is just an umbrella term. It's like, counting the number of dogs, but there's so many different breeds of dogs. So how can you possibly just count them all dogs? In a way, you need to look at, okay, Dalmatians, okay, Dachshunds, okay, Chihuahuas, okay, black dogs, white dogs. There's a lot of little details, instead of just saying this is the amount of dogs. It's the same with plastics. So there's a whole range of different types of plastics out there, and they all have different, they're made of different polymers like polyester and nylon. They have different dyes and additives on them. They come in all different sizes, different shapes, different colors. And so you can't have a method that detects a piece of plastic based off of its polymer, because then you're ignoring the rest, or based off of its shape or the way it looks like under a microscope, because you might be ignoring a few that look similar to, perhaps a piece of silt. And so it becomes really difficult to decide, okay, how will we determine microplastics concentrations, because there's such a mix. So what happens is you really have to go particle by particle from your sample to determine the actual amount of microplastics in total in your sample. This is just another example of what a microplastic filter might look like. So you can see that there's so many different types of plastics. You have fragments, you have fibers, you have large fragments, you have some foam pieces. And so it really becomes complicated. Another question you have to ask is, how fine should you filter samples to collect microplastics? So for example, this blue grid here is sort of my little representation of a filter mesh. And so what you see when you pass seawater through, you're going to get fibers and microbeads collecting on these filters. But whether or not these particles actually pass through the filter depends on the pore size. So the size of the openings inside of this mesh. Because if this pore size is too large, all of these plastics will just pass right through. And what you find with microplastics is that the smaller the plastic that you filter for, the larger abundance, the larger amount of plastics you'll actually get. And so you have to think about, okay, well, which pore size should I use to collect, a true estimate of the amount of plastics in the sample? But of course, you have to balance that with both time and sample volume, because the smaller you go, the more likely your filter is to fill up and clog. So no more solution can actually pass through, which increases the time you're sampling and a whole other slew of issues, because most samples have not just plastics, but all of these other particles that are not plastics. And so you really have to balance that. My team right now, we're working at measuring down to 10 microns, and we've chosen 10 microns because often fibers are about 10 microns thick or more. Another question you have to ask is, once you filter the water and once you have your sample and once you've identified your sample, you have to wonder, is this sample actually from the ocean or from the actual environment that I sampled, or is this from my sweater? Or is this from the rope that was on the boat? Or is this from contamination in the lab? And so you really have to be honest with yourself and with the people that you're collaborating with about the level that you're contaminating your samples. And so you need to avoid, exposing your samples to plastics. So this is sort of like we need to avoid this. And this is actually what I look like when I'm in the lab processing my samples. And so in addition to, being plastic clean, you also need to collect accurate blank samples. And blanks are basically, say I wanted to collect a sample of seawater, I wouldn't just bring one filter. I would also bring other filters that I don't filter, but I still expose to the environment that I sampled from, in case, maybe when I open my filter on the boat, say 5 fibers fly off my sweater, that in theory should also fly off into my blank sample, which is my clean filter that I also open on the boat. And so in total, all what we're doing here is collecting values from sources and fate and different movement throughout the strait to really create a model. We want to be able to predict the concentrations or the amounts of plastics in the water. We want to predict hotspots where there would be a large amount of plastics in the water. Where are wildlife most at risk? Is our Strait of Georgia an input of plastics to the North Pacific, or is it a sink? that's an open question. You know, how do we model degradation rates of plastics? You heard Kelly talk about, we really don't know how fast plastics are degrading. Well, a lot of the data that my group is collecting, not just concentrations from different sources, but also monitoring weathering states of the plastic, all of this data together can be put into a model to describe that degradation. And so if you use mathematics to balance all of this data and equations, you can really come up with a 3D predictive situation where you can accurately describe microplastics within the environment. And so these are just some of the collaborators that I work with. There's a whole range of people. These are just the supervisors. Under each of these names is, 3 to 10 other people that work on this project. And so it's a large project. And if you have any questions, just let me know or shoot me an email. Coincidentally, this image here is also of plastic found at Pachina Beach. This was when I visited Bamfield in the spring. And I also found a number of nurdles. You can see all these white circles here. And so that's my presentation. Thank you.
Lori, thank you so much for sharing that information for us. I know that there's a lot of kind of heavy material in there for folks that are now feeling that this is a big problem, and indeed it is a big problem. And this is why we have people like Lori and her team working on these kinds of issues. And believe me, there are other teams at other universities all across the world now that are starting to tackle these kinds of issues now that we've realized that it's become such a problem. So as we continue through our presentation, I'd love for you participants, those watching, to drop into the chat any ideas that you have for ways that you can reduce your own personal use of plastics from your day-to-day life. But also, this is a great opportunity for you to ask questions to either Lori or to our BMSC team here. And while we are doing that question period, we're also going to send the ROV back down underwater to have another look around at the life under the BMSC docks. Because now we know what's at stake, we can try and find some different species of animals that are found underwater here at BMSC. Lori, I just want to mention you had a really cool experiment set up in at the BMSC docks this spring. Do you want to maybe just describe that really briefly, what you were doing?
Sure. So that was a large project. We had a number of collaborators together, and basically what we did was we wanted to create sort of like mini oceans to see what happens as microplastic concentrations increase. So we put giant bags off the dock at Bamfield and filled them with the ambient seawater that had the entire plankton community from bacteria to zooplankton. And then we added to each bag increasing concentrations of plastic. So one bag had 10 plastics per liter, one had, another, all the way up to 50,000 plastics per liter. And then from there, we monitored changes to the community of bacteria in the water. We monitored changes to the phytoplankton. We monitored changes to the zooplankton and different toxic effects that the plastics might have or cause for zooplankton. We also monitored the fate of the plastics, and that was my domain of the project, which was looking at where the plastics move. So are they sinking? Where are they going? How much is ingested? How much ends up in marine snow, which is basically all of the shedding and debris from the biological organisms accumulating and sinking down, and looking at the degradation and weathering of the plastics as well. And that was for 2 months. That was a 2-month-long experiment.
It sounds like such a big project. You had so much going on there, and there were a lot of people involved in that research. It was really exciting to watch from the other people at BMSC who are really curious to know what's going on. And of course, in a research project, it takes a while for the results to be made available. We're just starting to get our ROV going. I think it's shut itself down at the moment, so we're stand by as it gets back into the water here. That's coming up. However, maybe we, oh yeah, there are a couple of questions coming into the chat too. A question of why litter is put in the ocean in the first place. Yeah, so obviously these days humans are making a much better effort to not put our trash into the ocean, but unfortunately it does still happen. And as it does happen in Canada, and it also happens in other countries in other parts of the world. Um, so this is something that still needs to be addressed to prevent plastics from making it into waterways. And I mean, I'm speaking about the ocean here because I'm standing right next to the ocean, but this actually applies to everyone who's tuning in, depending whether you're watching from Alberta or Ontario. And maybe if you're not located right at the seaside, your local waterways are still affected, and eventually they do empty into the ocean somewhere after a very long journey. So these are all things to consider in our daily lives. Anytime that we can reduce the amount of plastics that we are using, and it's hard because they're found in products everywhere. Anytime we can make a reduction in the amount of plastics we're using, then we can help to combat this problem. We are back under the docks with the ROV. This is super exciting to see the little fish communities that are down there. We are looking at, again, a piling, so the wooden posts that are supporting our dock, and there's tons of marine life that is inhabiting these posts over time. There's sea stars, that's an ochre star on there, crawling its way up and probably eating away at the other invertebrate animals that are living on there. And these are some lovely little juvenile rockfish that are swimming around the area as well. Great question. Why is the water green? The water is green for two reasons. One, it has to do with the amount of, hopefully not plastic, it actually has to do with the amount of plankton in the water. So plankton are tiny little live marine organisms. Some are plants, some are animals, but they're very small, and they're floating around in the water all over the place. And that's what the little bits are that you're seeing floating past the camera every now and then. It looks like snow underwater. Those are little bits of plankton. I mean, ideally they are not bits of plastic. It's possible that some of them are bits of plastic, but Lori soon will have a better idea of how much plastic is actually in the ocean in our area. That's what they're working on. The other reason that the water is green is it has to do with the way that the wavelengths of light get filtered out as you go deeper underwater. Yeah, the plankton themselves look white because the lights on the ROV are lighting them up. So they do look like snowflakes, which is kind of cool, but it makes it harder to see the other things in the distance. Like you can see this piling that's right in front of the camera, but back in the background, it's all just kind of murky green back there and you can't really see the details. That's pretty typical for this time of year, but the clarity of the water does improve in the winter months. So we'll be hopefully doing some more lessons like this in November, December. Those are great times of year to do some filming underwater because the water has a lot less plankton. You can see much further underwater. It's almost like swimming through a tunnel down here with all that snow flying past your face. We've got some seaweeds down here. Feel free to drop in the chat any of your own ways that you like to reduce your use of plastics in your day-to-day life. Or maybe recycle plastics. So Lori mentioned wearing a number of microplastics in her clothes. I confess I am also wearing microplastics in my clothing today, and probably many of you are as well. So one kind of simple solution that can be done is to install a filter in your washing machine that helps to trap and catch some of those plastics. And then there are, again, additional filters in wastewater treatment plants that catch even more of them, although some still do escape. There's a little fish, a little goby, and a orange sea cucumber is what that feathery look of tentacles is. That's part of the feeding tentacles of a sea cucumber. Something else that that can be done, lots of organizations around the world are realizing the extent of the plastic pollution problem in our oceans, and they're working to clean it up. The watch that I'm wearing is actually made of recycled ocean plastic. So that's kind of a cool feature. There's Adidas is making shoes that are made from recycled fishing nets. Lots of organizations are out there working to remove ghost gear, which is fishing gear that has been lost in the ocean. It's fallen overboard or been cut free or somehow ended up in the ocean. They're going and removing that gear from the environment so that it's no longer harming the fish or catching fish inadvertently. So lots of great work is being done. Let me know if you have any other ideas in the chat. Keep looking around. We have about 5 more minutes here before we have to sign off. Some of what we're seeing is seaweed. A lot of this sort of bigger brown shapes in our area. Seaweed is nice and abundant under the docks here. That's a good thing. Offers lots of great hiding places for tiny little marine life, little invertebrates and little fish. And we're actually lucky that we didn't really find that many other bits of trash in our ocean. We even sent the ROV down in a couple different places before today's lesson just to look and see what we could find. And we actually didn't find that much. It's kind of surprising. I expected there to be more plastic in Bamfield Inlet and other garbage in general, but we really didn't find that much. So that's a good sign. These under the docks here are a number of tube worms. That's what those kind of brownish, reddish, fluffy looking things are, with fish swimming in all around. Large white anemones are the fluffy parts, the whitish fluffy parts, different from the tube worm fluffy parts. Lots of fluffy things down there. And lots of fish. So we actually do have a really healthy ecosystem right under the docks in Bamfield. There is also some invasive species under the docks in Bamfield, though, that we are working on removing. We're constantly pulling that long stringy stuff off of the docks. That's a whole different conversation. And these are rockfish, all these little fish. Oh, that one actually I think was a perch, never mind. They're a mixture, different species of fish schooling together. And isn't it interesting that they don't seem bothered by the ROV being there? They're just doing their thing, living in their little fishy world, and not too concerned about the fact there's a little robot spying on them. Although I guess they don't know what it's doing down there. Pretty cool. I'm not seeing a lot of comments coming through from our viewers. So I guess I'll close with a couple of other little tidbits of advice for ways that you can reduce your own use of plastic on a day-to-day basis. One of the ones that I like to do often is I have a little portable set of bamboo utensils that I carry with me. And that is something useful you can do whenever you go, you're getting takeout food. They used to always give you a little plastic fork or knife or spoon. If you bring your own bamboo ones, you don't need to use those single-use plastics anymore. Things that you use one time and then throw away. And often you can't even recycle those kinds of things. So there's another great little solution. Every little bit helps. Simple, small changes in your own lifestyle can really improve the health of the environment overall. So little things is the place to start, that's for sure. I saw a question, are there any jellyfish? And the answer is yes, we do have jellyfish, although I don't think we've seen any with the ROV yet today. But we do have sea jellies in our area. There's lots of different species of them and lots of different sizes of them too. We also have crabs, yes. Often we find crabs climbing up and down the surface of the pilings, the wooden posts that we saw earlier. There's sometimes crabs stuck there, and that's a lot of fun. Also lots of sea cucumbers and fish. And now the ROV has reached the surface of the water. Yes, mussels too, they also grow on those pilings. So I would like to thank everyone for joining our lesson. Hopefully you learned a little bit about microplastics and ocean pollution today. And hopefully rather than you feeling really sad and overwhelmed by this, we're hoping that we've more inspired you to do something positive about it and make some simple small changes in your daily lives so that we can help to combat this problem. It's something that we all have to work on together. So on behalf of everyone here at the Bamfield Marine Sciences Center, thank you so much to Lori for joining and sharing her research out of UBC. That's awesome contribution. And to everyone here at Bamfield, Owen and Bianca and Phil and my other teammates here on the dock, it's been awesome talking to you today. Bye for now.